Okay, this is part 2 of the threads discussion. This slide is talking about forms of threads. The head types refer to the top of the thread. This will help you decide what type of tool that you need to tighten or loosen a thread. Will it be a flathead screwdriver, a Phillips screwdriver, a set screw, or a wrench or a nut driver? The fastener types on the right refer to the body. Is it a nut? These mate with a bolt. Is it a bolt or is it a screw? A good way to realize the difference between a bolt and a screw is that a bolt needs a receiving fastener, either a nut or an internal thread in another part, and a screw is just driven into a piece of material like a piece of wood or sheet metal, and there's no pre-existing internal thread for it. Okay. This slide lists the types of fasteners. We did talk about this a little briefly in part 1 already. This slide shows a close-up picture of what a thread looks like on a drawing. You can see that the external thread of a bolt or a screw on the left, the internal thread is shown on the right. Notice the section lines above and below the threaded area for the internal thread. This is shown as a section so you can see what the thread looks like inside the part. Just about all threads are manufactured according to the right-hand rule. What this means is that when you're above the head of the screw looking down, if you turn it to the right, it tightens, and if you turn it to the left, it loosens. Hence the common phrase, righty-tighty, lefty-loosey. That's where it comes from. Now, there are some threads that are reverse threads. These are called left-handed threads, and they have a designation of LH on the call-out and are usually noted with a symbol somewhere on the body of the screw or the bolt. The point of using left-hand threads is so something doesn't loosen on its own if it is spinning. Most of the threads in the United States are made with unified classifications. Elsewhere in the world, metric threads are used. We do not use metric threads a lot of times here in the US, but you can also buy metric threads if you need to. They will have an M in front of the size designation. We will talk about that a little bit more later. Now these slides 5 and 6, if you take a look at them, are going to review the parts of a thread and the terminology. You should take a look and make sure that you know those components. This slide here talks about how sizes are noted for threads. For unified threads, or the common threads in the US, they use an outside diameter in the threads per inch. For metric threads, it's different. They use the major diameter and the pitch. Remember, these metric threads will have an M in front of their major diameter. Something special about unified threads with really small threads, it doesn't make much sense to specify their outside diameter, so they go to a numbering system for anything smaller than 1/4 of an inch. You might hear a number 10 or a number 8 screw. You will see these sizes in a chart coming up soon. Also, it should be noted for unified threads, there are UN and UNR classifications. The difference is that UNR has a full radius on the bottom, so the fatigue life is improved. Now, each thread classification usually has 2 types of threads. They can have a coarse thread. This is coarse, spelled with an A, not a U, which means there are fewer threads per inch, or they can have a fine thread here, which means that there are more threads per inch. These are noted with the letters C and F as shown after the UN designation. So you would have UNC or UNF. This slide here is going to show you how the things are designated on the drawing. They're not dimensioned with extension lines and dimensions as we're used to dimensioning diameters, but instead they use the leaders as shown here. The leaders point to the actual thread, and then the designation is in a note format. It should be in this order always. It starts with the outside diameter, then it gives a dash, then it gives the threads per inch, then the UN designation or classification, then the class of fit, and the internal-external notification. Then an X follows, and then the length is given. If it is a left-hand thread, which it is not in here, you're going to show it with a dash and an LH placed at the end. Okay, this slide is a very important chart to use to determine the size of screws and bolts. There will be some questions in one of your assignments using this, so please make sure you understand how to use it. This is for unified threads only. There may be a separate chart that looks like this for metric, but we're only going to look at the unified today. The outside diameter is shown in the first column here, okay? And that's really the size of how it's sold, okay? You will notice that size is below 1/4 of an inch. You can see it right here. There's the 1/4 of an inch. The sizes below the 1/4 of an inch are shown with the numbers, the designations, okay? Whole number sizes. The decimal size is shown in actually column 2. You can see those right here. Okay? So for a 1/4 inch screw right here, you can see that the size given is 0.25 inches. The other 2 columns are for either the coarse or the fine threads. You're going to use one or the other, not both. So for a 3/4 inch screw, if you take a look at this right here, okay, it's 0.75 inches, okay? And if you use a coarse thread, you're going to have 10 threads per inch, okay? For a 3/4 inch fine thread screw, you will have 16 threads per inch here, okay? Try using it for this specification, okay? You might want to pause and listen, okay? For a 1-inch fine screw, what is the number of threads per inch? Pause the video here. You ready? It should have 12 threads per inch. One more practice. For a number 8 screw that's up here, okay, what is the outside diameter? Pause it here. If you look over, it is 0.1640. For a coarse number 8, how many threads per inch does it have? It's got 32. So hopefully that helps you with this chart. You might want to go back and rewind this and then kind of read it again so you know how to do that. On slide number 12, it gives you some more examples that you can try. Okay? Slides number 13 and 14, they're going to talk about the types of threads that are and where they should be used. I hope that you have used this information in these 2 slides for your essays that you've already written. Okay? This slide and this slide here. This next slide here is basically the last thing you need to know. This is how the threads are represented on drawings. The first one is pictorially. This is basically a snapshot or picture of the threads. It is drawn as it's seen. This can also be very complicated to draw and usually isn't shown this way on drawings because it takes so much time and it's very complex. The next way is schematically. Okay, this is the most common way of representing threads on a drawing. The last way is simplified. Yes, this is the easiest because it's really a series of 4 lines, but it's not recommended because it's hard to tell that it's a thread. You could easily confuse this type of thread with a hollow shaft. Now, instructions on how to actually draw these is in another document that I'll be uploading as well.